Hey, Mechalina here, and today I am doing a design with me video. I saw this nail polish bottle capper that you put on a bottle of nail polish that makes it easier to handle and more easy to paint. Online, the reference product looks like it's some sort of elastomer. I have a 3D printable TPU filament that I think will have that type of compliance we need to be able to fit over the different nail polish bottle caps, and I think it will work just fine. So let's dive into SolidWorks. I hope you all are having a wonderful week. It is time to do a Mechalina CAD with me. Yes, I plan to open my beer like that. The photo I have here is showing the nail polish cap we're making. It kind of looks like an egg glue. So how I'm breaking this shape down is there's going to be, I'm looking at it, it's my first time designing it. There is kind of this igloo dome shape, and then there's kind of this like revolve nail polish shape, and then it all sort of lives and has like this like flat portion here, and they blend together. So I'm gonna do mostly solid modeling and some combines to create this shape. I'll keep this reference image up. Let's go. Already created the part file here, and let's just start creating a geometry sketch. And I'm gonna actually sketch out everything on here to not create a solid feature, and then go back and convert those entities into different features. So this is kind of like my base model that will contain everything. Y'all know I like my infinite length center line. So I'll do that there, and I will sketch out the actual nail polish bottle. So I'll sketch out like something like this on the inside. Actually, I'll do one with a slight taper to make sure we know it fits. I want to make sure it fits my personal collection of nail polish bottles. All right, I didn't click the origin of that one. If you're following my keyboard shortcut settings, which I will upload soon, that was L to create lines. And let's taper in the inside. If you know you're gonna go eventually tapered, make sure you're not getting auto constraints of like verticals where you don't want verticals, and that you are starting your design with that taper in mind. So the first section I see, and I'm gonna enclose this here, is right now I'm doing this portion of the egg glue. So I'm only drawing half of it. I will be revolving things around this infinite length center line, so that's why it looks how it currently looks. The nail polish bottle I will make green, and these lines here I will make another color. I always use sketch colors, and this is just a visual guide and reference for me. And I will make this hot pink. Cool, so that's this portion. And now the next portion is the egg glue portion. So this egg glue portion, if you can imagine, this is like another dome revolve shape. So we have one revolve along this length here, and then we're gonna have another revolve around that length there. So first thing I'm gonna do is then create that revolve in the other direction. And so this here I know will be horizontal, and I will just start by creating a circle and doing something like that, and figuring out where the circle ends. So this is kind of funky because the top of the circle actually kind of blends with this surface here. And maybe if I switch directions like this, that would help. Give me one moment. All right, I just switched directions to make this a little more easy to visualize. And so again, I'm not putting dimension numbers since this is kind of a freehand sketch that I'm doing, but it's gonna look something like this, and then we want the flat of the dome to end where this kind of revolve stops. And what I mean by that is because I'm only drawing with the one side, I actually want to know where it falls on the other side. So I'm going to simply mirror those entities, and you know, it's totally fine. This is all kind of just reference geometry. Cool. So with this line, I know that is where I want to cut my circle. And so I'm going to do something like this. And actually wanted this to be a regular line. If you highlight the line and click G with my keyboard shortcuts, that will turn it back to regular. Trim entities, love my trim to closest, and we start having it here. And let's just delete these other excess segments there. And so now we have kind of the start of the overall shape here. And then for the egg glue shape, I am going to make that purple. Cool. So tangent, that's not really what I want here. What I want is for this to be tangent to a perpendicular line. So I am gonna create a little reference line up here and make that horizontal to this, or the other thing we can do is make it perpendicular to each other to make it a little more flexible. So holding both of those, perpendicular relation, and then let's take this line and this line, and let's make that tangent. Awesome. So that gives me kind of that shape I'm looking for. So as I deleted that vertical there, let's make that in this line collinear for now. And this we can begin to kind of mess with later, but let's just make sure that it will generally build. Do something like that. And I don't actually necessarily think the midpoint of the circle, okay, is there. Great. Let's get started and let's just start doing our solids and kind of see what this begins to look like. So again, I'm not creating my creatures from this. This is just our overall geometry sketch for visualization. On the same plane, we can start now building out the features. So the first thing I want to do is revolve that bottom feature. So I'm going to go here, 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 and I'm converting all these lines. Amazing. Sometimes those long lines don't show up unless you zoom way out. I just converted that into a geometry sketch. And then let's trim some entities. Cool. And the last thing is just to connect these two pieces. And then, yeah, that's the sketch for the tube that the bottle tip inserts to. Let's revolve. And yep, I picked the right line. Awesome. That's the bottom piece one. And then now let's do the revolve in the other direction for the dome of the igloo. So just start another sketch, right plane, and then let's convert the entities we care about. Convert. So center line, this line, gotta make sure it all connects. And then now I'm just connecting the dots here because I didn't originally draw that. line there. Let's trim the excess down here. It's fully enclosed. And now we can select this axis of revolution, and we want it to go all the way. So when SolidWorks auto selects thin features, that actually means this isn't a properly enclosed sketch. I could have selected it to work around it, but I can see actually this is the line I did not want. I think that was for the other feature. So I'm just gonna delete that. And then let's check shaded sketch contours. That still looks good. And let's revolve. Something like that. And we don't need to merge just yet. Awesome. So we now have our baseline shape. This kind of looks like that one character from WALL-E or something, you know what I'm saying? Alright, so I think this actually is starting to look pretty good, kind of the things I want. I'm not going to exactly mimic like this kind of flat bevel chamfer edge along the corners or all of that. Just kind of want the overall basic shape. But let's go in and start throwing some dimensions now that we're feeling good about this kind of freehand design. So going into the geometry sketch, clicking N to view normal to the plane. Let's start measuring some stuff. So there will be some compliance, and I think, you know, my TPE filament will stretch like, you know, a tiny bit, maybe like up to 1/8 of an inch. So if it's too big, this won't work, and if it's too tight, well, we want it a little tight so it can fit around the different nail polish balls. But you can go too big. So I'm gonna take my biggest nail polish cap and make sure that you still get a little bit of a fit here on this one, and so this one's just gonna be my baseline dimensions. And I will just be roughly measuring this, so measuring the diameter, and I have my calipers here, and we will just start measuring the outside, and it looks like I'm in millimeters today, and that is totally fine. So I'm also doing a little bit of rounding and rounding down to the nearest like 1/10 of a millimeter. So I'm just kind of roughing it out. So that's 17.8. Can't get a good measurement, but luckily this comes off, and then we're gonna get the overall height of this one. That was 41.9, and yeah, that's really all the main dimensions that I care about for that. Let's start editing the dimensions that go around it. And so one decision is, where do we want to bottom out? Do we want this to bottom out on this part of the nail polish bottle, or do we want it to bottom out from the top part, ramming up into it? Thinking about it, it probably doesn't matter. The big thing is we don't want the cap to get on the way if we want to screw this back down, but we probably want to remove the cap anyway. So I'm going to, at least with this nail polish cap, I will actually have this and this here flush or aligned, so I will make that go linear. And let's just give this a little bit of a gap in case there's like a significantly longer nail polish bottle. So I will add 5 millimeters there. Nice. And then as far as this wanting to fit or needing to fit, so the other thing that we need to consider is I also want to make sure I'm getting a tight squeeze on this bottle. So right now with the draft angle, this needs to go pretty far up to be able to match the diameter of this one per se. And I think we can compensate for that by adding another feature in later. I want to add like a crush rib feature, and I'll show you what that is if you're not familiar. So I think we can do actually like a pretty much like 1-to-1 fit on this little guy here. And so what I will actually do is I'm going to make this line parallel to this line. And I'm doing this really because I know like that my material is compliant and stretchy. And I'm pretty much just going to make, I know my 3D printing is a little off, so I'm just going to make this like 0.05 of a millimeter gap here. So just a hair's or so bigger. That looks great. Let's give like some overall thickness to this. I can't measure from this to this because I'm measuring 2 non-parallel lines, so I will have to measure from a point here to this vertical line here, and that is the thickness at kind of our minimum part here. It actually, I don't think it needs to be too thick. I think 3 millimeters there. It's just fine. And that's looking good. I'm just gonna exit my sketch here to be able to save and kind of see the updates. Let's go back in. Beer break. I just winked at the camera. I didn't like that. I'm not going to do that again. Alright, let's kind of play with this bad boy. So I don't got real life dimensions, so we just going to do what like looks stylish and hand holdable. You know, so what can fit nicely into the palm of my hand. Let's see if I can get back to that side view. Alright, I have the side view showing again. So some points I care about is maybe how much the crest of the dome sticks out from this portion here. And let's just say a tiny bit. I'm going to make that 2 millimeters. So bring that in a little closer. And then I also just generally, remember, we want to dimension like what we like really care about. And what I really care about is actually this overall height of the thing. And so I'm going to pick that point to that point. And then just with my calipers and my hand, I'm just going to see like what would be like something for me that's comfortable to hold. Another thing that I like to do is I always have Play-Doh around me or some sort of sculpting dough, and that just really helps to figure out like sizing and shapes and stuff when you're doing like handheld things or surfacing. So like, you know, what size shape is actually gonna help me you know, get that grip, that nice grip control, and paint my nails. So actually something about this big, at least for the spherical portion, and then a little more sticking out. So this, I have a spherical portion of about 60 millimeters in diameter. And then we said we want it to stick out a little bit for the bottom portion. So if you imagine this sphere were to continue down and around, like it would go down to this point, we have it sticking out a little. And when I say a little, maybe 15 millimeters. So let's actually make the total of this 75. Great. I'm going to turn off sketch colors to see what we have not restrained. Awesome. Actually, it looks like everything is pretty constrained except this reference geometry line, which doesn't really matter. But I'm just gonna tuck it away with this one here. And yeah, we have a fully defined sketch, which doesn't matter really for the geometry sketch, but you know, make sure it stables and doesn't update funky. And let's solve some problems. So we got some rebuild problems, which is no problem at all. Aha! So actually what I did before with that reference was breaking it. So what I'm going to do, just to keep this an enclosed profile, clicking L to start my line, I will just add some arbitrary thickness there. Yeah, I totally forgot that that reference line was to enclose the first profile, because I was picturing this to do this in 2 features. This distance doesn't really matter. I'm just going to say 1 because it's all in here and it is going to, we're eventually going to merge it together. Alright, and this is off too. So this is actually our center line. So I just converted that over, trimming the excess. And when we exit, let's see if that picks the right revolve. It airs out, no problem. The axis is not valid. It's valid now. Great, and now we have our basic shape, and we'll do my favorite thing, which is throwing lots and lots of fillets to smooth out some surfaces. So let's actually start by combining these features, and then let's add the detail features to help with the compliance of this bottom portion to be able to stretch with, you know, slightly bigger bottles and then work with slightly smaller bottles as well. Alright, so what we want to do is make sure we don't have this like overlap section in. If I were to do a section view, so that's clicking here and switching over to the right plane, you can see we have a major issue of this material being stuck in there. There's a lot of ways to do this. I'm going to do some subtract body features. So the first thing I'm going to do is create a subtract body that I want to subtract from, but I want to keep this original Revolve 3 because I like that. So the first thing I'm going to do is just copy the body of a Revolve 3. So, you know, this is move/copy, body to move is Revolve, and I don't want to move it, I don't want to do anything, so I just want to say copy. If I move to this menu, I like copy, click OK. I now have a copy of this. So I'm going to hide these 2 original features, and then let's turn this feature here into a solid feature. So I could fill this feature, I could do a lot of that stuff. This is not always work approved, but I will do a feature called delete face, which is a surface feature. We'll delete face and then have SolidWorks auto repair it with a patch. So if I were to delete this face and this face and show the preview, you'll see where it patches. And now we just created a full solid body of that. Delete face can kind of make your models a little sketchy sometimes. So it's not always advised to do that, but it's quick for this at-home tutorial. I'm gonna go now to the combine, subtract body. So you have, this is the main body. I wanna subtract this one I just made. And right now it looks like we have an error of 0 thickness geometry, which is probably the corner right here. So let's see what's going on. So that's something we can actually fit within the geometry sketch. It's actually, it doesn't like that it's completely aligned, because then it's aligning those surfaces at this intersection down here. Kind of strange. So to be able to fix that so it isn't as weird is I'm actually going to go ahead and extend the sphere a tiny bit. So there's a little bit of some overhang like that. If you're making a part exactly, this is maybe not a way I would recommend, but this for me right now is just a bit of a quick workaround, and I just want this to maybe overhang. Oops, I accidentally doubled that dimension. Let's make it significant. Let's make that overhang by like 1 millimeter. And I'm gonna have to go back and kind of like update the second revolve here. It's not gonna like that. I gotta reconvert some lines over. That's totally okay. So convert, convert, convert. This line here I'll leave, but let's make that construction. Let's make this construction. Can you hear Faraday in the background? I got a new mic here, and I hope you can't hear him as much as my previous videos. So there is an issue. The sketch is not fully connected, and there we go. The lines were connected. Sometimes a little wiggle fixes that. Alright, we have our Wally girlfriend, partner, BFF looking thing. And let's see if that fixes this problem. And voila, we now have the top igloo with a hollow thing. Then I'm going to bring back the revolve here. And I have my original piece here. See, when we did that subtract body, it deleted that body and it got absorbed into that feature. So that's why we had to create that duplicate. And then now I want to just combine these. And so this is one solid part. And voila, it is one solid part. And we are like getting there. I want to save this, and let me hide sketch lines for the crew here. Alright, let's do the crush rib features on this here. And so how should we do the crush rib features? Because if we did a straight extrude, we can't do that because this inside here is tapered. So many ways to go about this. I think what's going to work best is if we did a sweep along the path and started that, and then we created a circular pattern and could pick how many crush rib like things we want in this. So let's definitely start that. So the first thing I want to do is create the sweep path. So I'm going to cut through again the right plane. It's my favorite plane. And I just want to follow the path of the inside. So if I just click that inside surface and then did that intersection, it will give me 2 lines. I only need 1 line, so I'm going to delete this one here, and really, boom, that is the path of my swept path. So remember, a sweep is a path you want to sweep along, and the profile. So to create the profile line of this, I want to create a new plane, or I could sketch on this face. But to really make sure that I'm clicking the right spots on this is I want to actually use this sketch to derive my plane. So I'm going to click this point parallel to this face to create that. It's the same thing as that face, but just want to make sure that point is derived in case something gets wonky. So from that sketch, or plane, we start to sketch, and we can pick what we want our crush rib to look like. I want the crush rib to be like a half circle, and so if I drew a full circle here and have the midpoint resting, and that is connected, you always want, when you're doing a swept, you want to have a point of your sketch relating directly to the sketch path, and so that is my coincident there. And then for like a little crush rib, we probably want the rib to stick in like 2 millimeters, so that's a radius of 2, or because we're dimensioning diameter here, that would be a diameter of about 4 millimeters. Cool. I don't need to do anything else with this because I will be merging the solids, so I'm totally okay with that overhanging there. I'm gonna go to features. We'll go to our swept feature. There is our sketch profile. Here is our path. And then I don't need to mess with any of the other features, and boom, there is my crush rib there. You know, I will be printing this out of TPE. That's kind of semi-hollow. It has an infill pattern, so I don't want to make this necessarily hollow itself. So I'm totally fine with that feature. Now with this feature, let's circular pattern it. And how many do we want? 4, 6, 5 if you're edgy. And so the first thing, so I said we're going to do 6, but let's go in order of this circular pattern wizard. So the direction is that initial axis. So I'm going to just select that from our first sketch. 360 degrees all the way around, and then 6 here. I actually don't think we need 6. I'm going to use an odd number. I feel like 3 is going to be good, and then when you're doing circular things, actually things will be more balanced out with, you know, 3, like a 3-legged stool versus like a 4-legged stool, if you know what I mean. So we can just do that and say 3. Cool, so that kind of finishes out all the technical features there. Going to save, and that's a beer. Alright, and then let's just start making this look beautiful, and let's throw some fillets on it. And I'm just gonna like eyeball it and whatnot. So something else that I noticed in this design that they did is they have these little cool stretchy relief things to make it really open up and stretchable or like compliant. It's like a stress relief to allow it to like open up at those points. I don't think we really need that, but you know what? I kind of like this dome feature actually. Hold the fillets. Remember, we always try to do our fillets and chamfer features last. Let's do this cute dome feature, and hell, let's just throw like a logo or something cute on it too. So there is actually a dome feature within SolidWorks. I could have actually made this dome-like feature with the dome feature in SolidWorks, but just wanted to show you how we can get a little more fancy with Revolve. So I wanted to find the outside of this dome here, and so basically I'm gonna draw where I want that dome to start and end. So I just drew a circle, and I want a little bit of that edge. Let's kind of match the thickness of our other material. So we'll do 3 millimeters, and I think that is good here. And so for the dome feature to work is you actually have to select a face to apply the dome to. We don't want to apply the dome to the whole face. You only want to apply the dome to the inside of the face. So what we're going to be doing here is splitting this face into two faces, the outer ring and then the inner circle. And we can do this with some cool features. Let's see if I haven't used this one in a while. Let's see if it's on my feature command bar. Curves, here we go. And so we want to take this curve and then be able to project it and then split it onto the part. So I'm gonna select this sketch, this face, click OK, and then now you'll see I have a curve there of what I want. And then I want to be able to split that. Hold on, let's rewind. All right, so what we want to do is split that face. So that is curve, split line. Select the sketch, select the face you want to split, and it is a projection. We want this to like project down onto that face. And now we have a split here, and now we can apply that cool dome feature I was talking about. If we go to Insert, Features, Dome, you see we selected this face. Let's do a little bit of a side view to see what's happening. Let's say I want my dome to inset in 1 millimeter, and if I reverse it, you can see how that kind of has this nice stylized inset in. Let's see what happens if I increase it more, and I'm kind of just eyeballing it. I think that looks good. Can you see the dome? For us to like actually see that dome we did, we can just apply some view features on it. And if we did curvature zebra stripes, that will help us kind of see like what's going on with the curve. So maybe that helps you there to see, like, if this was a flat surface, this would be all like one continuous gradient color, but instead you can kind of see how that hits in, so that it was in view, and that's just a display thing. I'm gonna turn that off. And then also, if we just did an intersection, a section view, you can see we have our dome here. Nice. The last thing I want to do is now, second to last thing is I'm gonna apply that logo now to our dome shape here. And I will, remember, we can't just directly draw on curved surfaces. We always have to draw on a plane, on a flat, a 2D sketch on a flat. And so I just created a plane off of that surface. And we will go sketch. And So we're gonna use the text sketch feature. So you have to just define a line of where you want your text to fall, and the text can live above or below this line. And then when I'll click now sketch text, I'm gonna click that curve, that's gonna define it. And this is the Mechalina thing. So this is using the current document fonts. Let's just bump it up. How big do you want it? Let's make it 6.5. And it's cutting off because my curve is not big enough here. And let's try that again. I accidentally exited out just there. Let's make it center. Doesn't have to be as big, maybe like 5 meters in height. Cool. I'm gonna click OK to that. And I'm just going to kind of move this to where I think the text should live. Something like that. And then I think that text looks good. All right, with that now as a sketch, we can basically use it as a sketch, and we can cut extrude into it to create our little indentation there for our logo. So I don't want it to cut, well, I guess we'll just have it cut straight to a flat. I could say we could cut extrude it to a curved surface to match the original surface and whatnot. You know what, actually, let's just do that. So let's create the surface that the cut extrude will end at. So we're creating that end condition feature. So I am going to hide this plane. So that's gonna get in the way of me selecting. We'll go to offset surface. Cool. And let's say the depth of cut is about 1 millimeter, and we'll offset that surface, not outwards, but inwards. Great, and then for this to go back in here, we do need to make sure, right now this is just text, we wanna actually convert this into an entity that we can use to cut into. So if I say not dissolve sketch text, let me see. All right, now we have the offset surface, and we can now take our sketch here that we made, do an extruded cut, and again, stop it at that end condition. So from the sketch plane, and we'll go up to surface, and we're gonna say our surface we just made, and let's click OK. And now we have a cut there that is also curved and nice and matching all of that good stuff. Great. Finally, the time we've been waiting for. Super fillet time. Let's add in our fillets and start connecting some of the parts that we have here. So the first one I'm gonna fillet is this line here to be able to connect it. So let's look at that front view and then kind of see what we want to do with this. Let's bump that up a little more. Let's see how far we can get it. Maybe even a little more, 25. That really blends it out. I think that looks cool. So let's click OK. And now we have those two parts all blended with just a symmetrical fillet there. You can see some differences between the original part. The original part actually has this flat that carries all the way down, but you know, this is kind of just my inaccurate, lazy weeknight version of it. Looking at it, I think that's really all I wanted out of this part. I think this looks really great. Sorry for clapping right by my microphone just now. I hope you learned something, or just watching to chill out, maybe pick up some fun techniques. That delete face one was kind of a fun one I did tonight. And I hope you all have a great week and CAD away. Please like and subscribe if you like what you saw, and throw some comments below of what you would like to see for my next CAD with me or SolidWorks tutorial. Alright, bye everyone.